In this video, we are going to talk about another machine learning algorithm, and this is also a supervised machine learning algorithm. And this is the linear regression algorithm. This is the simplest machine learning algorithm that is available, not only in data science but also in terms of Tableau as well. There are the fewest steps that we need to follow to create prediction based upon this algorithm. Okay. So here is my workbook on Tableau Public, whom I've named Linear Regression Study/Rs. And there is this sheet called Linear Regression, in which all the analysis has been done already, but we won't be using this. We would be creating our own analysis. So let me just clear this sheet. Before that, let's just talk about this data source. So here I have the data source in which the number of hours is given, that is how many hours a student studies, and then what is the score that he has got. It is all given. Okay, so there are 25 records that we get in this data set. This is a very simple data set, a very simple example, so that we are able to easily understand that how a machine learning algorithm, the linear regression algorithm, is gonna work. Okay. So here is a sheet which I have named linear regression. And how are we going to work with it? Let's just see that. These are the two measures that we have, that is the hours and the scores. So we can get them over here, that is the number of hours and the number of scores. It doesn't matter where they are. That means if you want, you can just swap them as well, but it won't matter. The thing that's going to matter is this aggregate measures. You can just remove them. So this is the number of the hours studied, and this is the scores that the student has get. If you see, there is a linear trend between the two. That means if the student has studied for a more number of hours, then he's getting a better score, right? Similarly, if you just swap those values, the trend is same. That means it doesn't matter with swapping, because in linear regression, we have something that is called as the correlation between the two values. So this is a positive correlation. That means as the hours increase, the scores is also increasing, and the positive correlation is same whether you compare hours versus scores or you compare scores versus hours, right? So it doesn't matter. What does matter is this degree of positive correlation. Like you can see, there is a simple line that you can draw, and those points would be just working on that line, right? But still there are a few here and there points which of course are there to make sure that our model doesn't get 100% accuracy, and we are just gonna ignore them. Okay, now this is what we have got. If I just change its type to a line, so this is the kind of the line that we're getting. You see, it's not a perfectly straight line, but still it's giving us a positive correlation, right? So what we do is we go to analytics for the linear regression algorithm I'm talking about, and this is the model, the trend line model, which we're going to use. You can just make sure your mouse is clicked and you drag it. Now there are these 5 types of trend lines that you can create, and how are you going to choose which one to create? You see, there is this line that is given with these points. You have to compare it with what your points are going to look like, right? So let me just drop it for a second, and for a better view, let's just change it to automatic. So these are the points. Now if you just grab your line, you see your points are looking like this. That is a linear trend. If you see your points are showing a curve kind of a trend, or an exponential trend, or polynomial trend, or a power kind of a trend, you have to choose your line accordingly. So I'm just gonna drop it into this linear, because this is the trend being shown by my points, right? You see, this is the linear trend line that I have got. Now we can just select this. So if you just select this is something that we are getting. That is 9.7758 multiplied by hours plus something, and then we are getting the scores. So what is this? This is the equation of the line. If you have learned about the line equation, then you might recall that the equation of a line is in a form y equals mx plus c, right? So this is exactly what we are getting. Y is scores that we are trying to predict. M is the slope of the line, which is given as 9.7758, multiplied by the x parameter, that is the parameter which we have, which is the hours parameter. plus c, that is the intercept. The intercept value is this 2.48367. So the basic work in the linear regression algorithm is to find this value of m and c. Now once we have find out the value of m and c, if we just provide any value of x or any of the values of the r's, then it would give us the corresponding value of scores. Of course that won't be 100% accurate, but it would be pretty good assumption made by our machine learning algorithm. So this is the prediction that the algorithm will do. Here there is one more value known as the r squared value, that is 0.952948. That means the accuracy of the model is pretty high. That means higher the r squared value, the better the quality of the model is. That means it's almost closer to 1. That means it is a very good model. Okay, the r square value is the more it's closer to 1, the better the model. Then we have p value, which should be less than 0.0001, which is again another indication that our model is working pretty good. Okay, now we have this option to edit. If you just select on edit, here what we can do is we can just select the different types of the lines. If you want a logarithmic line, so you selected logarithmic, so it's changed into a logarithmic line. If you select on exponential, this changed into an exponential line. You selected on power, it changed into the line of a power. If you selected on a polynomial, you can provide a degree. Right now it's 3. If you provide 2, so that would be changed into a power of degree 2. If you select like 5, to change into of degree 5. Okay, so if you see this degree 5 looks pretty much more suited than the linear regression, like this line. Okay, so I'm just gonna click on OK, and now if I just select on this r square value, of course it's better, but the model is being overfitted, because I know for these data points that we are getting, this line is considered to be good. It's considered correct. That's why I can work with it for this data. But in the case we are working with any of the unseen data, then those points might lie on the line and we might get incorrect results. So this would hamper the overall accuracy of the model. Thus this is the concept of overfitting, which I have shown to you. Now what I'm going to do is edit it and get it back to a linear model or a linear line. And what I'm going to do is make sure the show confidence bands is there and click on OK. Now these confidence bands show that this might be the range of the errors, like whichever points lie in that, they are also gonna be considered. Okay, now you want to change the way the line looks, you can of course change it from here, but I'm not gonna go that way. Now if you right click, there is this option to describe trend line. Now this describe trend line gives us the values such as the p values and the equation of the line. So this is the line equation. If you want, you can just copy this data and paste it or show it to others. Now here is this coefficients value, that is the term is r's, and the value of the intercept, and what is the standard error in that. Of course nothing is 100% accurate. That's what the machine learning algorithm also understands. That's why it's giving us a measure of standard error, that what is the error it thinks has occurred in this particular kind of model, and it accepts that error and it is showing the extent of that particular error. You can close it. Next what we have, if we just right click over here, we have this describe trend model. Now what is this describe trend model? It gives us a lot of values, a lot of information, like a linear trend model is computed for scores given r's. The model may be significant at p less than equal to 0.05. So whenever the value of p is less than or equal to 0.05, then that model is significant. Right now if you see the value of p is less than 0.0001, that means this model is significant. Okay, and this model, what is it does, it scores are computed if the number of r's are given. There is a lot of information given about the model that we would be seeing in the next video in this particular describe trend model dialog box. Thanks for watching this video.